Hello, my name is Thomas Sibas. I've built an Arduino controlled 10x6 LED matrix on which I've coded some games. In this video I'll show you the games I've created, first the software, and then I'll show you how the matrix was built, so the hardware. I'm doing this video in essence to keep track of the project, to share it with friends or other people. If you happen to have some Arduino programmation or electronic knowledge, and you have some comments or feedback on how to improve all this, I'd be grateful to receive it. I'm a complete amateur. I'm learning by myself, so let me know. I hope you find it cool. So let me show you first the games, and the first one I have to show is this racing game, which is inspired by a well-known karting game. That's the coolest I have, I must say. So first of all, you choose your player, either the red M or the green L, and that selects your player color. So if you choose one, you have your car at the bottom of the screen and you have walls that you must dodge using the controller. So you have your small car and you dodge the walls coming at you. If you take a wall, you die and you have a score. The score is computed by how far you've been. So here, every time I pass a line, I get 1 point and my score increases. At the start, the walls are very dense and you have just little holes. Yeah, and when you hit a wall, you have a score display like 0, 1, 5, 3, so 153 points here. So what I was saying is that the walls at the start are very broad, you can see, with small holes just to pass by. But the game is very slow, so you have time to learn. You can also catch stars like this, in which case you can go through walls and it gives you tons of points. And there's also a little explosion when you hit the wall. So, at the start the walls are big, and you just go through a small, and you see the game is moving forward and forward. And it's getting harder to avoid the walls. So yeah, if you get a star, you can explode tons of walls, and you get bonus points, and the game is not accelerating because of these bonus points. The score is also displayed on top of the screen in binary. You might have saw it in the red dot. So here 5, 9, 8, 5, almost 600 points. Yeah, when we code this game, we also make sure that after you catch a star, you have some time to catch your breath. So you make sure you don't there's not a wall you want to hit because you're yellow, and just before you hit it, it turns white and you lose. We also try to do a bit of math to ensure that if you go through a hole and the next wall gives you some space here, you have some time to go from here to here, and that is doable. Yeah, and this is essentially it. We've coded this one with a friend of mine, Matteo. We thought of it together, we brainstormed about it, and then we even pair-programmed it remotely by sharing screen and all that. And we agreed on improvements, how we could make the game better, and implemented them together and all. So it was really cool to do that with you. Thanks a lot for your help, Matteo. It was a really cool project. Then the next game I can show is the one I actually started the whole project for. It was a simple snake. So you know Snake. I'm flashing it on the Arduino right now. It's actually the worst coded. It was the one I started with, and I was a bit lazy and not wanted to code everything, so I found I figured there was some existing code for Snake on the web. So I thought, why not reuse it? It turned out it was a poorly written code and not... Oh, just lost. I hit myself. It was a poorly written code, and I just made some fix, and it was not adapted for the Arduino and all that. But yeah. Not gonna play too long on this one. Lost again. The next one I have, I coded to learn a bit more about the memory of the Arduino and how it works. So there are many the level of memories, just a flash memory, and then deeper memories that even get saved when you turn the Arduino off. So I tried a maze game. So here you have the guy you're playing for, and you're moving around, and you must find the exit of the maze. So the maze is way bigger than the screen, if you wish, and it's saved in a dedicated memory space. I originally wanted to do something way cooler than just a maze, like for instance having like a menace or something growing in the maze and trying to catch you and all that. But it wasn't working out with the memory. I couldn't see the state of the menace. Well, so yeah, just a small maze game. And the last one I'm working on currently is one that is inspired by Slenderman, the famous PC game, where the player has to escape an enemy who gets nearer and nearer. You have to catch some white pages, and you have to catch 8 of them, and every time you catch one, the enemy gets closer and goes faster. So yeah, here's the little guy going in the door of the castle, and here you have your little guy. He's moving around, there's a white page, nothing at all. And when you catch the first page, the enemy appears, and he tries to catch you. So I had to do a small pathfinding game, nothing too complex, to make sure he tries to catch you. And if you catch the second page, then he goes a bit faster. And as you catch the third one, he goes even faster. Fourth one, faster. Until some point where it's going to be really hard to escape him. Yeah, he catches me. And he ate my little guy. So that's just all for now. I'm trying to make this game a bit more appealing with some reward things. So yeah, that's essentially the games I have. The 4 I have. So I'll now show you the hardware a bit. So that's the LED matrix. Essentially, it's been built based on these kind of LEDs. These are, let me read, WS2812B. I'll put something in the comments for all that, of course. These are individually adjustable LEDs that are on the strip. You can originally buy them on the internet on that format. So they are rolled over, and you can have that as many as you want. Here it's the 60 LEDs per meter option, and you can simply cut them on the copper, and you can adjust them individually using the fast LED library. So you have the power coming here with a plus and a minus on each strip, and you have the yellow data pin. So the data pin allows you using the fast LED library to address each one, and it goes in a certain direction. So the code sees this as just one LED strip, as if it was in this way. But with a little mathematical trick, you can make it see it like a matrix. So it goes this way, and then it goes this way. You could have them all going the same way, but the point then is that you'd have to solder this one with the next one here, and to make it go this way. So I have the columns going in different orders, but you can just solve it in the code. So yeah, that's the prototype I used before doing this one, and over it I've put first some plexiglass to protect them, then a white sheet of dense paper that artists used to draw on, I think, and then another second layer of plexiglass to protect the paper. So that gives you something a bit like this, and you have this gluing it all together. It's just glue that holds it. Yeah, so that's essentially the LED matrix. That's how it's built. And below it you have the actual Arduino and all that. So let me show you. I'll just try to zoom a bit. Here goes. So the Arduino is built, so here is the Arduino, and these are the electronic components. My wife thought it was cool if it was shown on the board. This is a 4.5 volt with 3 batteries powering up the LED matrix, and this is a 9 volt powering up the Arduino. This is the computer plug, and you have the plug here. This 4.5 volts comes here. Here you have a small condensator, just to avoid power spikes to the LED matrix. And you have the data pin here, going out from here, going there, and in the board to make this all work. Additionally to this, you have, so that's just the LED board. And for this, and to control it, I've also built a small controller like this. This is just like usual buttons you get with the Arduino. And I've just took two pieces of food, made it smooth, and I've soldered it inside. It's a bit dirty, no PCB. You have the 5V coming in with the red cable, and then you have the data pin and the ground pin going back with this white cables. It goes all the way up here inside the board, where this white one has four cables each, and then from the board it gets inside all the way here, and that gets out here. There is the resistance here for the data pins, and then all that gets back to the Arduino itself. I've also added a blue and a green diode that I'm not using so far. I saw a game on Reddit called Hunt the Wumpus that might be fun to try to code, so these might be useful for this game especially. And also a small piezo buzzer for the music, for the 8-bit music, but I didn't use it yet. I'm trying to make it work in parallel of the games. Yeah, and that seems pretty much it. So Arduino LED matrix 6x10 with the 2 power source, the ground connected of course, the piezo, the 2 LEDs, and the controller and the games. All the code you can find on my GitHub. Please be nice. As I said, I'm really an amateur. And yeah, the next steps I want to build is the same kind of thing, but rather than having it into a frame, you would have it inside a table, like a small IKEA table. So you can use, I plan to use that kind of thing, which is a 16x16 WS2812B LED matrix, each individually adjustable, the same system in the ID. So I'd have 4 to make a 32x32. And additionally, I plan to use this Arduino Mega, which has way more memory and power. And finally, use this SNES controller. You can actually use them quite easily. There's tutorial online. I'm using this to make the cable longer, and at the other end, you can just plug that into the Arduino, and it's quite easy to use actually. So yeah, maybe I'll do another video when I have finished this. So yeah, I think that's pretty much it. Thanks for watching. I hope it was of interest to someone somewhere. And yeah, just for the recording for my friends, here's the setup I had to do for to do this video, just to keep the camera steady. Yeah. So yeah, thanks for watching. Bye.